Welcome everyone. In this video, we will solve a GATE 2019 question in which we have to find out the average voltage calculation across the output load. Okay, in a diode resistance based circuitry. So this is a diode and resistance based circuitry. So in the question, it is given Vs is a square wave of period t. Okay, so Vs is the square wave of period t. Okay, with maximum value of 8 volt and minimum minus 10 volt. Okay, and the square wave is given, and we have to assume the diode is ideal one and the resistance R1 R2 value is 50 ohm. So we have to find out the value of VL, load average voltage of the load, that is our VL. So basically what we have to do, we have to draw the output response of this circuit. Okay, output response, that is our VL and T. So this one is our M. So if we find this VL, we can easily say what is the average value of VL. So okay, so in this situation, so first we have to think about when the time between 0 to t by 2. Okay, so I am considering case 1. Okay, case 1, when t value lie in between 0 to t by 2. Okay, so in between 0 to t by 2, 0 to t by 2. Okay, in this region, okay, 0 to t by 2, we can say the diode will be off. Okay, because this one is positive voltage, so diode will be in reverse bias. So in this case, d will be off. Okay, and the voltage Vs is nothing but simply 8 volt. Diode will be off because it will be in reverse bias. Okay, we are looking for the condition 1. So now the circuit configuration will be more or less, we can say this one is plus or minus, say this should be, just think about 8 volt, and this one will be, diode will be open circuited, so make it open, and the resistance will be like that. Okay, and one more resistance will be come here, this one for the case 1. Okay, and I am saying this voltage will be VL. Okay, and this one is our R1 and R2. Okay, if we remodify the same circuit, what we will get, 8 volt is there, R1 is there, and R2 is there, and this value will be VL. So by applying simple voltage division rule, we can find the voltage VL, that is our 8 volt into R2. Okay, R2 divided by R1 plus R2. So we can write as 8. R2 is how much? R2 and R1 is 50. So 50 by 50 plus 50. Okay, we can write as 400 by 100. So it should be 4 volt. Okay, so VL value is now 4 volt in between 0 to t by 2. So I am making 0 and this point say t by 2. So in this point, the value is nothing but simply 4 volt. So we can make it 4 volt. Okay, now we have to consider case 2. Okay, I am writing here. I am writing here case 2. Case 2, when time vary from t by 2 to t. When time vary from t by 2 to t, this one, this region. Okay, when time vary from t by 2 to t. So in this case, we can say the value of Vs is nothing but simply our minus 10 volt, and this one is negative. Okay, so this should be diode will be in forward bias and D will be, we can say, on, or it is in the forward bias. Forward bias. Okay, so now we can modify the circuit. Okay, so how we can modify the circuit? We can say this should be minus plus and make this one as a simply write Vs. Okay, this diode will be forward bias, so this should be short circuited and the resistance will be there, and one more resistance. So this one is our R1, R2, and this value will be our plus of minus BL. So now this one is the sorted one. So if we again modify the circuit, or this one simply Vs, that is our minus 10 volt. Okay, we have to take the sorted one because current will flow from this one, because this one is high resistance will offered by the resistance, so current will flow through directly from the source circuited path, and this one will be the direct R2. Okay, and this value is nothing but simply our VL. So VL is nothing but simply our same voltage that is appear across the source, that is our Vs, and now in this case our voltage is minus 10 volt. So the output response across the VL is nothing but simply our minus 10 volt. VL is our now minus 10 volt. So now we can draw the, I am writing T here, and if we draw the output response, say this one is somehow 10. Okay, so this region when D is in the off state. Okay, and the below region, the below one, when the D is in the on region. Okay, when D equals to on or D off. Okay, so now this one is the output, voltage output. Okay, that is our VL. Now in the question we have to find the average value of VL. So for the average value of VL we have to find, I am writing here, average value of VL we have to find. Okay, for the calculation of average value of VL, what we have to do, just we have to take the area. For the time being I am saying this area is, say I am taking the red color, A1 and A2. The average value, that is our VL average, is nothing but simply the time period of that particular signal, okay, up to this one, by area, the whole area. This one is the concept of average. So I am saying A1, A2. A1 is the area between the time 0 to t by 2, and A2 is also area for the time t by 2 to t. Okay, so 1 by t, A1 plus A2 is the average. For average calculation, if you know the waveform, you have to find the area. If sinusoidal, we have to take the integration type of thing, but this one is a rectangular type, a square shape waveform, so it is very easy to find the area. So area bounded by this whole region we have to find. So this value we can write as 1 by t, the period of the signal. Okay, we are not going for the other period. Okay, or it will repeat itself. Okay, so no need to repeat here. Now area for A1 is nothing but simply 4 volt, 4 into t by 2. this length 4 and this length is t by 2. So 4 into t by 2. Now this length is also t by 2 and this one is minus 10. So we can write as minus 10 this one into t by 2. Okay. So what we can write, this should be our 2 and this should be our 5. If we take t common, okay, so t by t and this should be 2 minus 5. Okay, this tt will be cancelled out, so it should be minus 3 volt. So we can easily say the VL value is now minus 3 volt. So this one is the average value of the voltage, average value of the voltage. So this value will be our minus 3 volt. Okay, so this one is the correct way to solve this type of question. So some diode will be there, some resistance, so we have to take the case 1. Okay, in case 1 we have to think D is off and Vs is 8 volts, so we have to modify the circuit. Then we have to draw the voltage waveform across the VL in between 0 to T by 2. In the next case, we have to go for the case 2 for the time period T by 2 to T. So diode is on, so it will follow through this one, low resistance path. So the modified circuit is this one. From this one, we can get the value of VL minus 10 volt. So now we have made the waveform. After that, we have to find the average value of VL. So for the average value of VL, what we have to do, every for the average value of VL, we have to take the average for the time period 0 to t. Okay, so 1 by t area A1 plus A2 area. So if we do this simple calculation, so this will become minus 3 volt. So this one VL is our VL is the average. VL average equals to minus 3 volt. So in that way, we have to solve this type of question. So this is a simple question, but we have to know the concept of average value. Okay. So this is all about this question. So thank you for watching this video.